So first of all, I'm really flattered and honored to be a recipient of the Rota Prize. Thank you, Silvana, for a great introduction. And to join the ranks of the previous winners, which include a list of, crazy good economists. So I'm, really honored to be part of them and to share the prize with Costanza and Konstantin and Alexandra, of course, great researchers with a bright future. So let's dive right into my paper, which connects to some of the points that Silvana was talking about on carbon pricing and on distributional consequences of it. Well, carbon pricing and in particular carbon taxes have been the silver bullet of climate economists, at least since the 70s, since the prices versus quantities paper by Marty Weitzman in 74. They've been the chosen market-based instruments to address climate mitigation. And why is that? Because carbon taxes in particular focus on efficiency and on achieving emission reductions at the least cost. Now, this is going to be an important part of this paper. So, of course, we are going to take into account equity considerations and hence the regressiveness. Now, the paper itself talks about co-benefits. So, in particular, air quality co-benefits. So it doesn't deal with carbon per se, but it deals with unintended consequences of climate policy. So I'll first give you an overview of the paper in 4 slides. So if we run long, then we still have an idea of what the study talks about. And then I'll just dive deeper into the content. Right. So why is it important to study co-benefits in the context of climate mitigation? Well, fossil fuel processes emit carbon, but also a set of air pollutants. And so they result in complementary externalities. One is the global carbon externality, and one is the local air quality externality. So regulating one through a carbon tax is possible of reducing concentrations of the others and then give rise to hidden co-benefits in terms of air quality improvements. So there's a study by the Lancet on climate change and health in 2015 that hailed carbon pricing and in particular carbon taxes as the greatest global health opportunities of the 21st century. Now, a totally different set but correlated set of concerns is due to environmental justice questions. What are these? Well, there's a burgeoning literature that explains that different socioeconomic groups are exposed to different environmental problems in different ways, with the least advantaged groups being more exposed than the most advantaged groups. So by focusing on efficiency, a carbon tax is blind to equity considerations, but it's important to consider those in order to enhance the palatability of climate instruments. And of course, I mean, we live in Italy. We know that we don't have a carbon tax at the moment in our country, and it will be politically unfeasible to put in place one. But air quality and air quality co-benefits are large enough in magnitude that they can tilt CBA of carbon taxations and then make it much more politically feasible. So just a few words about the setting of this study. This is based in British Columbia. Why is that so? Well, we have a long-standing scheme, a long-standing carbon tax in BC that goes back to 2008. It was hailed from by the World Bank and by the IMF as the grand policy experiment in climate change mitigation. It's an ideal setting to study this issue because it's subnational and it's a salient tax. That means it's a tax that has reduced emissions and had an effect on gasoline and diesel consumption in a disproportionate way as to a price change. Then we have a long post-intervention period. There are no competing policies in other Canadian provinces, so the pool of control units is unaffected by any confounding issues. And the transportation sector, which is the focus of my study, bears the lion's share of emissions in the province. In terms of equity, why is it important? The tax was ex ante considered to be regressive on the income dimension, and so it was pegged as a revenue-neutral carbon tax, where the revenues are distributed back to the population through low-income carbon credits that go to benefit the lowest segments of the socioeconomic distribution. So in this study, what I'm going to see is how the co-benefits or second-order effects are distributed as well. Now, research questions. The first one is, pretty fundamental and dry. Has the carbon tax actually resulted in any reductions in air pollutants concentrations? In particular, I'm focusing on PM2.5 in BC versus comparable control units. Second set of questions is that concerning environmental justice gaps, and I'm focusing on these 4 axes, which are correlated amongst each other, but at the same time, they do explore different dimensions. One is the pollution gap, so to say, where polluted areas stay more polluted. The pollution density gap addresses the fact that denser areas are usually more polluted in terms of air quality, but at the same time are more efficient in terms of carbon emissions. Because, of course, by being denser, routes and commutes are shorter, and so they save carbon. A third channel and a fourth channel are the most interesting from a socioeconomic perspective, and they're the pollution income gap, where richer areas are usually less polluted, and the ethnic diversity gap, where areas in which minorities live are usually much more polluted. And this is especially true in the US, and this is the first study that does it for Canada. Then I explore the mechanisms, which I'm probably not going to have time to talk about today. And most importantly, the welfare gains from co-benefits. One thing that this study does is that we convert these changes in air pollution concentrations into health, into monetized health changes. Finally, just a spoiler of the results, in case I don't make it, I do find a 5 to 10% drop in PM2.5 concentrations in BC. And this drop is regressive. So what does it mean, regressive along the environmental justice dimension? Well, reductions happen everywhere. And so the policy is actually Pareto optimal for what concerns air quality. Everybody sees reductions. So you couldn't make anybody better off without subtracting from somebody else. But these reductions increase the environmental justice gaps. And so richer areas get more reductions compared to poorer areas. And the same is true for ethnic diverse areas that see lower reductions compared to less ethnically diverse areas. And same for density and pollution. Now, what underlies the result is a reduction in fuel demand, gasoline and diesel. So there's no fuel substitution, well, or not a lot of evidence of it. And then a switch away from cars and towards public transport. So the tax is salient in changing people's behavior. Finally, when converting the health, the reductions in air pollutants into health benefits using the value of a statistical life, I find large health benefits per capita that were around $200, which is double the low-income action credit that I was mentioning before for revenue neutrality. When comparing the annualized stream of co-benefits to the revenue from carbon taxes, we get a 40 to 81% ratio of co-benefits to revenues. And this is consistent with the simulation literature, which predicts partial to full offsets of climate mitigation costs. But also the health co-benefits, which are not directly related to the heterogeneity in PM2.5 reductions, are also regressive in the environmental justice dimension. And this depends on the underlying distribution of the population, as we will see in a minute. Right, so just a clarification, and I've made it clear, we only talk about PM2.5, not the rest of the set of air pollutants that are emitted in fossil fuel combustion processes in transport, NO2 and so on, just PM2.5 here. And the effects that I consider on human health are just the immediate health effects, morbidity and mortality from respiratory and cardiovascular diseases. So whole set of non-health effects, which are burgeoning literature is now estimating, are not considered. So any effect that you see from my study is going to be a lower bound at most. Right. Just a bit of placement in the literature. There's a set of simulation studies that, as I said, claim that co-benefits can partially or fully offset climate mitigation costs. Empirical evidence of actually realized co-benefits from market-based instruments, it's pretty sporadic, and it's limited to cap-and-trade schemes mostly, mostly in the US, but also in the UTS case. At the same time, there is one study that just came out this year that focuses on fuel taxation. This is excise taxes and not carbon taxes, whereas my study is the first one that focuses specifically on a carbon tax. In terms of the environmental justice question, the results are just mixed. I mean, we don't have enough schemes. And as Silvana was saying, results are also a lot of context dependent. And so they depend on the underlying distribution of pollution, ex ante, of population, of density, and on behavioral patterns in different jurisdictions. But it would be wrong to claim that market-based instruments necessarily reduce environmental justice gaps, because they can, like, the effect ex ante is unknown, And in my paper, for example, we see a regressive effect. Right. Context, tax was introduced in 2008 at a very low price for today's standards, $10 per ton of carbon equivalent, meant to be ramping up by $5 each calendar year, but it was stopped in 2012 at $30 per ton of carbon for 6 years. Now it's exploding back up and it's rolled out on a federal level, but this is out of my sample. My sample ends in 2017. At the same time, it's a low price by today's standards, but it was a very high and ambitious carbon tax by 2008 standards. There is a bit of evidence, as I said, that the tax is salient, so it has reduced gasoline and diesel demand. And there is some evidence that it has worked on CO2 emissions in the transportation sector. Right. So data, I want to be really brief here because I don't have much time, but I just want to tell you what's the structure of my data. I'm using dissemination areas, which is the equivalent to US census tracts, so very fine-grained geometries over Canada's metropolitan areas. I only focus on urban areas. So of course, by focusing on transportation, patterns outside of metropolitan areas are not that interesting and not that dense, especially in a country like Canada. 3 of them are in BC, 23 of CMAs are outside BC, large panel over 19 years. This is what it looks like. For Vancouver metro area, on the top, you have PM 2.5 population density. On the middle row, you have median income and visible minority percentage. This is ethnic fragmentation, basically. And on the bottom, you have commute patterns. High emission commutes, which is car, motorcycles, and public transport here. So a lot of spatial correlation here, which will also explain the heterogeneous effects in terms of environmental justice. But this is just to give you an idea of what's the structure of the data at the baseline, meaning these are averages over the 3 years prior to the implementation of the carbon tax. Right. So empirics, what do I do? I mean, standard classic diff and diff just to start and just to unmask the problems with standard diff and diff in this context. We have parallel trends issues, but also we have substantial heterogeneity pre-treatment. And so if we just go here in blue, you can see all of the observations jittered around the year in which they are observed for BC, and in red, you can see all control units at the same time. I had to jitter because otherwise it's illegible. And we can see how the trends for control units are just much more heterogeneous than for BC. And also a test of trends prior to the implementation fails to identify parallel trends. Right. I augment it with coarse and exact matching just to bridge the gap to more nuanced methods that I'm using later in the analysis. And I match on outcome lags, but also on covariates. And then I run parametric diff and diff with the coarse and exact matching weights. And this basically already kind of solves the issue, but I'm not satisfied with that. And so I move to synthetic control methods in their extension to multiple treated units, which are able to reproduce an outcome path that is consistent between treated and control units. And my preferred method is actually the newly implemented synthetic diff and diff by the Arkangelski and co-authors group, which basically combines synthetic controls and diff and diff by adding time weights lambda that allow the synthetic control estimator to produce parallel trends prior to the intervention. I estimate the variance with 10,000 bootstrap runs. It's a very computationally intensive procedure, but yeah, lucky to have a high performance computer there. Right. So results, just a table of the main result with all 5 methods. And we can see immediately how diff and diff on the very left-hand side stands out as being the positive and significant result, whereas all the other methods which ensure kind of parallel trends pre-treatment identify a negative and significant result on emission. This is microgram per cubic meter. And this is, so the synthetic diff and diff result here is about, it corresponds to about a 6% reduction. Now, why diff and diff? Why is diff and diff clearly biased? Well, we can see kind of heterogeneous trend when this is in averages. Of course, this masks already heterogeneity, but we can see how the slopes of the 2 curves are already not parallel prior to the interventions, whereas synthetic control in the middle establishes a pretty perfect outcome path before the intervention, and synthetic diff and diff, by giving more weight to some time periods that are essential in the estimation, basically has a perfectly parallel trend in the 4 years prior to the intervention. Right, so these results, of course, I test the robustness with a different set of specifications. I use different satellite data for the outcome variable. I restrict the analysis to Vancouver only, just to check whether they're still consistent when considering the biggest metro area in British Columbia. Then I restrict the analysis to census tracts, basically that match the location of air quality monitors that are deployed on the ground. And I use the data from the monitor themselves, and all these checks confirm the trend of my main result. Now, mechanisms, I think I'm going to gloss over, but just give you the intuition that I use this causal-arima method by Fiammetta, Menchetti, and co-authors at the University of Florence, just published in the Journal of Econometrics, to study these high-dimensional volatile processes over time. And I find positive, well, negative effects, so reduction in demand of gasoline and diesel for BC over my study period. Also, I test switches in commute mode from car-centric commutes to public transport. I'm just going to give you a quick overview of the results. There are 5 to 6% reduction in car-centric commutes using different diff augmented with synthetic different diff weights, and an increase, a specular, almost specular increase in public transport. So behavioral adjustment by citizens is there. Much more important and much and more of the focus of today's presentation and of the paper itself is the dynamics of environmental justice, so, which I'm also gonna explain briefly. But what I do here is I take my synthetic different diff methodology, which is my preferred one. I introduce a quintile style approach for the first time, and I break the treatment unit, so BC, in quintiles of the 4 dimensions that I've illustrated earlier: pollution, population density, income, and ethnic diversity. Just a recap of how they're distributed over time. So these are the quintiles actually, and you can see, so I'm gonna run a separate regression for each quintile of these characteristics at the baseline. What I find are pretty monotonic effects. So if you consider the median income is basically the reverse in terms of privilege of minorities, densities, and PM 2.5 ex ante, the results are pretty monotonic. So lower results, which on these graphs are on the y-axis, they're higher because the graph is in the negative numbers. Lower results for the most advantaged categories throughout. So areas that are less polluted, well, more polluted, more dense, with a higher percentage of visible minorities, and that are poorer, and higher results for the opposite. So clearly, against a backdrop of reduced emissions, repressive dynamics in terms of PM 2.5, in terms of the evolution of these gaps. Final exercise of the paper is the conversion of these reductions, estimated actually through this heterogeneous pathway, into a change in depths. And this is, I'm using a formula from Meredith Fowley in the ER, adjusted with hazard rates from the environmental health literature. I use 2 just for robustness because the calculation is very sensitive to the hazard rate. And I use actual population at the baseline at the DA level, and gamma naught is actually calibrated rates of respiratory diseases and cardiovascular diseases at the DA level as well. Finally, I use the concept of a value of a statistical life in the very last equation to convert the change in deaths in a change in welfare. And what I get synthetically are these two maps. Now for the full distribution of CMAs. On the left-hand side, you have mortality reductions per 1,000 people. And on the right-hand side, you have the converted health gains in terms of dollars. And again, they are very correlated. If you think back, if you take Vancouver and you think back of the map of deprivation, let's call it, they are very correlated with the most deprived areas in a negative fashion. So lowest benefits in the most deprived areas. So again, an environmentally, a regressive environmental effect. So in terms of quantification, the central estimates of these health gains is about $200 per capita annually. Of course, there's bounds using different results and different data. This is 2 times the credit that was designed by the regulator to be given to socioeconomically disadvantaged groups. So co-benefits actually matter and can sway the perception of climate policy. When we aggregate them over the entire sample, they're $0.5 to $1.2 billion flow of co-benefits annually. And this is comparable to the carbon tax revenue at maturity. So in 2012, it's just a ratio going from 40 to 81% of those revenues. So they are comparable. They are in the same order of magnitude, and they should be considered in climate policy. So yeah, just concluding here, just reiterating that the tax has resulted in significant co-benefits. These are results per se in the magnitude of 5 to 10% reductions, which is not revolutionary, but not small. These results are also associated with the increase of environmental justice discrepancies along several axes, and the health gains associated with these are large in absolute and per capita terms, and also regressively distributed. So when we design climate policy, so we design a carbon tax, we can think that it's going to have a great impact in terms of course, climate mitigation. It's also going to have a whole set of co-benefits, which are important to be considered ex ante because they can alter cost-benefit analysis. But at the same time, if we really want to maximize gains, then we can abide to a principle that economists have known for decades, at least since the 50s, the one policy goal, one instrument. If we layer instruments one on top of the other and we internalize sets of externalities, we can focus on efficiency and focus on equity and obtain the greatest policy gains. So that's all for today. Thank you so much for having me here. And yeah, again, thank you for your time. Cheers. Oh, sure. Yeah.
Whether the choice of looking only at PM2 could make any sense. The sources, for example, I mean, even just looking at particulate matter, the sources of PM10 and PM5 are not the same.
Yeah.
And being more worse as pollutant, PM10 may come from motor cars. Could be that the reduction in pollution that you observe benefiting more which part of the population could somehow depend on the choice of.
Yeah, I mean, yeah, absolutely. Yeah.
And by the way, why? I mean, the data, where you have data on for PM5, usually you also have the ones.
So the thing is, the data for PM10 is not available at the same level of resolution for the same time frame. But something that we can have is NO2. So I'm working on NO2 actually now, just to have a trade-off, because usually it's emitted more by diesel and so on. So but diesel is not prevalent in BC. So, there's a lot of trade-offs. One thing that I'm really concerned with these trade-offs in emissions is actually residential emissions, which are much more skewed towards the PM10 spectrum. And so that, but that's, I think, beyond the scope of this paper that goes and analyzes transportation, but it would be a nice companion paper. For sure.
Even just looking at transportation. Even in different places.
Yeah.
And also the urban structure matters a lot. Have cities where the most polluted areas are also religious ones. Because they're a city center and not
Mm-hmm.
And you have instead
Absolutely.
residential areas in different contexts.
Agreed. I think this is much more specific. This study is much more specific for the North America part of the population, well, of the world, where you can have structures where density is not necessarily associated with wealth. I mean, barring New York City, but Vancouver, for example, is a city where denser areas are the poorer areas. And so this can, be replicated in other cities of the US, but not necessarily, for example, in Europe. So yeah, there's that for sure. It's constantly dependent.
Doesn't, of course, subtract anything to the value of either.
No, but my idea here is that, I'm criticizing a literature that claims that market-based instruments will necessarily have an effect on environmental justice gaps, and it's going to be a positive effect. And my point is exactly that it's, yeah. Thank you. Sure.
Are you concerned that your results is exactly
Absolutely.
and other people stop using here?
Global financial crisis.
Yes, because they focused on the leasing of cars
Right.
and like there's a big issue.
Yeah.
Like this.
Yeah.
And then also, yeah, you don't share your
No, it does. And there are a few confounders that should be considered. I'm actually working on them. In the wind element for sure. Another one is the wildfires, but I don't have them in my sample, like because I'm focusing on urban areas. The areas are so small that wind circulation is not necessary. I mean, I'm testing them, but it's the prevalent winds apparently are consistent with the results I've said. On the financial crisis, yes, clearly. One thing that could be tested is using pre and post data on at the census tract level, use of cars, and so on. And honestly, I'm not seeing much change, and I'm not seeing that big of an effect on livelihoods as well. But also, I'm using a counterfactual that has experienced a symmetric crisis because it's all Canada, right? So this is like my main shield is that I'm using a policy that's subnational, and so while it's clearly possible that BC was affected more than other provinces, Vancouver and Toronto probably had to experience similar shocks. That's my logic here. But yeah, valid point. All good? Great.
Before we knew your plans, I have a question to you.
Right.
I don't know if you have some. You get a good demonstration about the effectiveness of. What about the trajectory in the carbon technologies? If I consider the thermal power from now in the same in other car we changing technology and also technology which of the effect is potentially spontaneous and how much.
That's a great point. Yeah, I think it's a concern that I definitely have, and maybe I do have some graphs that can give us an idea. Okay, so extreme technological substitution. Only like the only problem I have with these graphs is that the data is a bit limited, but extreme technological substitution. So the advent of electric cars, battery electric, plug-in hybrids, and so on starts in 2017. As you can see, the point here. Basically, that's when it picks up, and now everybody drives Teslas in Vancouver. That's the story. Everybody has them, but it was very stable until that point. So I'm not really concerned about that. I think it's more like reductions in demand. At the same time, and I don't have that graph instead, but I do have the composition of the fleet in terms of SUVs and trucks and normal cars, and there's similar rates of renewals across all provinces of Canada. So I'm not really concerned about that because it's a process that happens throughout the sample, and so it's not really susceptible of biasing my estimates, I think. But it's a valid point.
And you think that reach the level of carbon tax to have to boost an effect that is really more impacting because we demonstrated that an impact is positive, but also is mild in terms of area decarbonization. So should we consider that the carbon tax should be
Yeah, mind you that I'm not showing an effect on carbon. I'm showing an effect on air quality, right? But there is an effect on carbon, and it is mild, and I agree. Now it's the $1 million question, right? Now, if you think of the Gilets jaunes, then you started high.
you want your chocolate?
Yeah, right. Yeah, fair enough. No, but I don't know if I have the answer. That's the story. I mean, yeah, if you think of France, they started high, then they had the Gilets jaunes, they had to repeal the tax, and so the trade-off there is policy versus politics, and what you do. Of course, like my view would be put it high and do give a lot of rebates to low-income households, but then again, you could have a rebound effect. It's really hard to disentangle, but yeah, that would be my choice. Have a high carbon tax and also calculate with other instruments because it's not magic bullet.
Very good job. Thank you.